How the Sun Produces Heat and Light by Kelly Smith. Most people are aware that they would not be able to live without the sun. They know it is the center of the solar system in which all planets are in orbit around. It is in fact 99.8% of the entire solar system's mass, and Earth could fit inside the sun roughly 1 million times. While we may only feel the sun at 100 degrees Fahrenheit on Earth, it is actually 10,000 degrees Fahrenheit. This is because the sun is 93 million miles away from the Earth. The sun keeps us alive by producing this light and heat, but how exactly does this happen? This essay is a further look into the ways the sun is able to create enough heat and light to sustain human life. To begin, I will discuss the structure and composition of the sun to help further explain how it heats and lightens the Earth. The sun is made up of layers of gas that vary in density and temperature. The sun is divided into 7 regions listed here from the inside of the sun to the outside. First, the core, the radiation zone, the convection zone, the photosphere, the chromosphere, the transition region, and the corona. The core is the innermost layer with a temperature over 15 million degrees Kelvin. It is a very dense region, meaning the gases are arranged tightly and packed closely together. Because of these hot and dense characteristics, many nuclear reactions take place in the core of the sun. These nuclear reactions, caused by numerous particles colliding with each other, are the source of energy for the sun. The radiation zone is the next layer, which explains the way the sun transfers its energy, through radiation. The convection zone is next, and is the zone that temperatures drop to only 2 million degrees. These 3 regions make up the interior part of the sun. Now, traveling further outwards in the sun is the photosphere. The photosphere is actually the innermost layer that can be seen by the human eye here on Earth. It is also known for having sunspots, which are the darker regions that are constantly changing. The next layer is a chromosphere, which is a 2,000 kilometer thick layer of gas, also known as the sphere of color. We then have the transition region, which is a rather thin layer in which temperatures begin to drastically increase. Finally, the corona, the outermost layer of the sun, is a thin layer in which humans can only see during a total solar eclipse. The 3 main regions to focus on are the core, which is 1/4 of the sun, the radiation zone, almost 1/2 of the sun, and the convection zone, which is about 3/10 of the sun. These 3 areas, as stated above, make up the majority of the sun's composition. With a better understanding of the sun's composition, the way the sun works should be easier to comprehend. The sun gives off energy in the form of light and heat, and the simplest way to describe this is by saying the sun produces energy through nuclear fusion reactions. The fact that these fusions are able to send heat and light from the sun all the way to the Earth, which is 93 million miles as previously mentioned, is absolutely amazing. There are a few important processes that occur in different layers of the sun that we will explain in depth. Each layer plays a vital part in producing light and heat and essentially keeping human life sustainable on Earth. These processes begin first in the core of the sun. Initially, the sun is primarily made up of hydrogen. The high density of the core creates a very high pressure. With this pressure and the high temperatures of the core, 4 hydrogen nuclei are pushed together so tightly that they form a helium atom. The remainder of the hydrogen atoms is then converted into energy, but in the form of light instead of heat. These nuclear fusions in the core produce roughly 99% of the heat created by the sun. From here, the heat is simply transferred through processes like radiation and convection in other parts of the sun. Before proceeding with some of the next processes, I want to discuss radiation. Radiation is a process in which electromagnetic waves are emitted to transfer heat from one object to another. These electromagnetic waves produced during the fusion in the core include infrared rays, ultraviolet rays, gamma rays, and even X-rays. These electromagnetic waves travel to the Earth as visible light. When it reaches the Earth's atmosphere, the atmosphere will absorb some of the electromagnetic radiation, while the rest will continue to Earth. The ultraviolet waves specifically are taken in by the ozone layer of the atmosphere in order to warm the stratosphere. While some of the radiation is absorbed by the atmosphere to heat it, the others will warm the Earth by traveling all the way to its surface. Many people are aware of the greenhouse effect, which is a topic that becomes relevant here. The greenhouse gases cause the atmosphere to take in more heat than it normally would. Therefore, the atmosphere now has excess heat. Consequently, the amount of electromagnetic radiation that passes through the atmosphere will decrease, resulting in the greenhouse effect. The process of the sun heating and lighting the Earth will now continue in this radiation zone. The nuclear fusion that was happening in the core is no longer taking place, but instead a process called radiation that I have just discussed. In the radiation zone, the hydrogen and helium ions begin to release photons that are soon absorbed by other ions. This transfers the heat and continues to push the heat outwards from the center of the sun to the Earth. It will actually take about 8 minutes for radiation to transfer the heat from the sun to the Earth. Convection is now an important term to understand, as heat is transferred into the convection zone and processes continue to transfer this heat. The convection zone is completely made up of plasma used to conduct electrical currents. The bottom of the convection zone receives its warmth from the radiation zone, while the top layers of the convection zone are cooler because light is being created. As a result, the convection zone is an area characterized by massive differences in temperature between the top layer and the bottom layer. Here is where the term convection comes up. An article I researched gave the example of boiling a pot of water to explain this term, which I found very helpful. At first, all the water in the pot is the exact same temperature. However, after the stove eye is turned on, the water at the bottom of the pot becomes hotter and hotter until the water is eventually released as bubbles at the top. Hot water is lighter than the cold water. Therefore, a continuous cycle is thus created. This explains the process of convection and how it transfers its energy in the form of heat from the radiation zone to the far edge of the convection zone. Thermal cells have a continuous cycle of transferring heat out to the photosphere as they rise, then falling back down, receiving more heat to then rise again. However, the heat transfer in this layer is not as productive as what is seen in the core and the radiation zone. The rotational leads of the Earth act on the occurrences in the convection zone, which results in the production of electrical currents and the creation of magnetic fields. This shows how light is produced and transferred. This newly created magnetic field bunches together to create magnetic flux tubes, which we have all learned about before. Because it is lighter than the surrounding atmosphere, it has a tendency to move toward its surface, and this results in transferring light. The field lines are elastic and unending, meaning that it is extremely difficult to alter them. However, if a line is somehow deformed, it is able to later reconnect in an X form. The dynamo theory of the sun is a theory that says a rotating and electrically conducting fluid is able to sustain its magnetic field over an astronomical time period. This theory explains the way the magnetic fields are transferred to send light to Earth. The magnetic field travels to the end of the convection zone, stops, and there it remains in a region that they call the overshooting region. In conclusion, it is incredible to think about all the processes that have to occur in order for the sun to heat and light the Earth. It is a topic that is rather difficult to understand. Perhaps some people never even consider the way this happens. I know before this project, I had never really thought of it. They know the sun keeps them alive by both warming and lighting the Earth, but then we never know anything about the nuclear fusions, the radiation, the convection, and the magnetic fields that also exist. Each of these broad topics contains tiny minuscule happenings that occur to make these processes work. Heat and light are transferred in various ways through the different layers of the sun and the atmosphere to finally reach the Earth and maintain human life. Here are my works cited. The end.